The dawn of the atomic age forever changed the course of human history. In a flash brighter than 1,000 suns, the world entered a new era of unprecedented destructive power and global tension. This is the story of how the atomic bomb came to be. The roots of the atomic bomb stretch back to the early 20th century. In 1905, Albert Einstein published his theory of special relativity, introducing the famous equation E equals mc squared. This equation suggested that a small amount of matter could be converted into an enormous amount of energy. However, it would take decades before this theoretical concept could be harnessed for practical applications. The discovery of nuclear fission in 1938 by German chemists Otto Hahn and Fritz Strassmann set the stage for the development of atomic weapons. They found that bombarding uranium with neutrons could split its atoms, releasing massive amounts of energy. This breakthrough caught the attention of physicists worldwide, including those who had fled Nazi Germany and were now living in the United States. As World War II raged across Europe, fears grew that Nazi Germany might be working on an atomic weapon. In 1939, Hungarian-American physicists Leo Szilard and Albert Einstein wrote a letter to President Franklin D. Roosevelt warning him of this possibility and urging the United States to begin its own nuclear research program. Roosevelt heeded their warning, and in 1942, the top-secret Manhattan Project was born. This massive undertaking, led by General Leslie Groves and physicist J. Robert Oppenheimer, brought together the brightest scientific minds from across the Allied nations. The project employed over 130,000 people and cost nearly $2 billion, equivalent to about $23 billion today. The Manhattan Project operated in multiple locations across the United States. The main research and design facility was established at Los Alamos, New Mexico. Here, scientists worked tirelessly to solve the complex problems of nuclear fission and weapon design. Other crucial sites included Oak Ridge, Tennessee, where uranium was enriched, and Hanford, Washington, where plutonium was produced. The project faced numerous challenges. One of the most significant was producing enough fissile material, either highly enriched uranium or plutonium, to create a bomb. This required the development of entirely new industrial processes on a massive scale. Another major hurdle was designing a mechanism to bring the fissile material together quickly enough to create a supercritical mass and trigger the nuclear chain reaction. As the work progressed, two distinct bomb designs emerged. The first, codenamed Little Boy, used enriched uranium and a relatively simple gun-type detonation mechanism. The second, known as Fat Man, used plutonium and required a more complex implosion-type design. On July 16, 1945, the fruits of the Manhattan Project's labor were put to the test. In the pre-dawn darkness of the New Mexico desert, the world's first atomic bomb was detonated. The test, codenamed Trinity, exceeded even the scientists' expectations. The explosion was equivalent to 20,000 tons of TNT, creating a mushroom cloud that rose 8 miles into the sky. Oppenheimer, watching the explosion, was reminded of a line from the Hindu scripture, the Bhagavad Gita, "Now I am become death, the destroyer of worlds." The awesome power of the atomic bomb had been unleashed, and there was no turning back. Less than a month after the Trinity test, on August 6, 1945, the uranium bomb, Little Boy, was dropped on Hiroshima, Japan. 3 days later, the plutonium bomb Fat Man was detonated over Nagasaki. The destruction was unprecedented. Tens of thousands of people were killed instantly, and many more would die in the following weeks, months, and years from injuries and radiation exposure. The use of atomic bombs against Japan remains one of the most controversial decisions in military history. Supporters argue that it hastened the end of World War II and saved lives by avoiding a land invasion of Japan. Critics contend that the bombings were unnecessary and constituted a war crime against civilians. The development and use of atomic weapons had profound and far-reaching consequences. It brought about the immediate surrender of Japan, effectively ending World War II. However, it also ushered in the Cold War era, characterized by an arms race between the United States and the Soviet Union, and the constant threat of nuclear annihilation. The invention of the atomic bomb fundamentally altered international relations, military strategy, and the very nature of global conflict. It led to the development of even more powerful thermonuclear weapons and sparked worldwide debates about nuclear proliferation and disarmament that continue to this day. The legacy of the Manhattan Project extends far beyond its military applications. The immense scientific and technological advancements made during the project paved the way for peaceful applications of nuclear energy, as well as developments in fields such as medicine, materials science, and computer technology. Today, more than 75 years after the first atomic bomb was detonated, we continue to grapple with its legacy. The invention of nuclear weapons remains a testament to human ingenuity and a stark reminder of our capacity for destruction. It serves as a powerful symbol of the ethical responsibilities that come with scientific advancement and the ongoing challenge of harnessing technology for the benefit of humanity while safeguarding against its potential for devastation. The story of the atomic bomb is a complex tapestry of scientific discovery, wartime urgency, ethical dilemmas, and world-altering consequences. It stands as a pivotal moment in human history, one that continues to shape our world and challenge our notions of progress, power, and moral responsibility.